students who all have come here to attend this special training program which we have designed for you for fundamentals of elevating. And we have Mr. Jagdish, who's an expert elevator consultant, who will be taking you through this session. And I'm glad that you guys have made time to come and understand the potential of a very sunshine industry. I think this will give you some opportunity to see what are the opportunities you have in these kind of fields. So this is a very, very important session, and I hope that you guys take back some good information from here. Over to you, Jagdish.
Thank you, Anita ma'am. Good afternoon all. Today we are going to talk about the fundamentals of vertical transportation. So I represent this company called Lavenir Consultancy Private Limited. We are basically vertical transportation consultants. Our business verticals are vertical transportation consulting, and I also publish a magazine called Elevator Digest, which talks about the technology and the latest innovations which are happening in the elevator industry. So what is vertical transportation? Vertical transportation is nothing but building lifeline. Without that, tall buildings or skyscrapers could have still remained a dream. What does vertical transportation consists of? The main products what we talk about here are elevators, escalators and moving walks. Elevators escalators moving walks are nothing but the travelators is the other word which is used. Let's talk about elevators. A little bit on the history of elevators. The first reference to an elevator or some sort of a lifting system was given in the time 287 BC to 212 BC by a Roman architect called Vitruvius, and probably it was not really a elevator, but it was a hoist kind of thing which was used to lift equipment. And there was again lot of people tried doing lot of innovations on how to lift people and the goods up, and the invention system based on a screw drive technique was one of the important steps in the elevator technology history. The first screw drive elevator was built by one Mr. Ivan Kublin, which was installed in Winter Palace in Moscow in 1793. Then later in 1823 in London, something was called as a ascending room or a big stage which goes up or lifted up by architects Burton and Homer at the London Colosseum, where the customers can go on to that ascending room, go up and have a good view of the London city. Then there was a belt driven elevator in 1835 developed by Frost and Strutt in England called the Teagle. And later John Roebling, he had invented the wire rope or the steel rope which gave the stability to the weight of the elevator and the counterweight which is balancing the elevator, which was probably one of the important steps in actually taking this invention forward. So when we talk of elevators and safety in elevators, Elisha Greaves Otis, who was the main person who has invented safety elevator. What does a safety elevator mean? Even if the ropes which are holding the elevator are cut, the elevator is not going to fall down, but with clutch action and overspeed governor mechanism, it stays wherever it is when it crosses the rated speed. So he actually in 1853 in New York Crystal Palace exhibition, he has demonstrated this very iconic picture in the elevator history, you can call it. And with the advent of that, the skyscrapers started coming up in the world. So today's skyscrapers, by today's standards, pre-war skyscrapers were amazingly over elevated, I should say. There was no real study done or a design done, how many number of floors, how many employees, how many number of elevators required and all was not really taken care of. But yeah, in 1930 Chrysler building, 77 stories served by 30 elevators, 20 of them signal controls. So, why I am saying this is, you need to have a proper study of the number of people in the building, number of floors in the building, and how many number of elevators, what capacity, what speed is required. That is called nothing but, it is called as vertical transportation traffic design. So, what are the objectives of a traffic study? Literally given here, to recommend or propose ideal vertical transportation system where handling capacity is equal to the traffic flow at critical period with acceptable waiting interval. Now, I will make it simple for you. That means morning up peak, if you take morning 9 a.m. to 10 a.m. people are coming into a office building. For example, we take a office building as a reference, IT office building or something like that. So, when people come in 5-minute period, if say 15% of the building population is coming in, your elevators designed or number of elevators provided should be able to handle that 15% of the people arriving into the building and taking them to their destination. In that 15% should be handled. What should be the waiting interval? Everything has been studied, and in our national building code and international building codes, there are clear parameters given for waiting interval, average waiting time, and handling capacity percentage. I think some glitch, will just check it out. Yeah. So, as I was telling you, the quantity of service, which is the handling capacity, quality of service, which is waiting interval and average waiting time. You look at the traffic flow, predominantly up peak in office buildings, then lunch hour and evening time, group operation, then the population of the buildings are critical aspects. So, the application of traffic study can be done in airports, commercial buildings, residential buildings, hotel sector, so on and so forth. So, the type of occupancy, the people who are occupying, single purpose occupancy or single tenancy it is called. For example, like a building like Wipro or Infosys, where the same company or of employees are occupying the entire building, or a diversified building which is a commercial building, each floor different companies are occupying those floors. Handling capacity, as I told you, is the passenger handling capacity during a 5-minute during peak period. Waiting interval, passengers waiting time, these both are critical aspects. Waiting interval is nothing but, if there are 4 elevators, the time taken between the successive arrivals of the lift cars in the main entry is the waiting interval. And when you press the button, wait for the elevator doors open and you go inside, is called average waiting time. Literally, average waiting time means nothing but, you press the button, you may get the elevator in 2 seconds, or longest waiting time would be, you press the button, you wait for the elevator for a longer period of time. So, these are some of the handling capacity recommended ranges, and the waiting interval recommended ranges. Now, National Building Code IS 17900, which is coming in now, gives certain guidelines or recommendatory codes which say that, how many number of floors, what should be the speed of elevators and things like that as a base. And you can also look at the kind of desirable plans of shaft layouts. Architects will be interested in this. So, how the layout should be, how the layout should not be or not ideal to provide this thing. Now, elevators are with 2 models predominantly. One being the elevators with machine room, that means there is a shaft the machine, controller, everything is placed in a room above the elevator shaft. Then there is another model which has come based on the request of architects. Companies have researched and provided some solution like what is called as a machine roomless equipment. So the machine, controller, all these components are placed within the elevator shaft and there is no machine room, so that the architects can use the space and even the building entire facade would look more better, no machine rooms jutting out. So what do we look at? Basically, the ideal dimensional details or the base dimensional details required are like, how many number of persons, what is the load. As per the National Building Code, currently 68 kg is taken as a person and it is transformed into number of persons. Then what should be the speed of elevators? Then the elevator well shaft sizes and the elevator car size correspondingly. What should be the entrance? And elevator, as you have seen earlier, there is a pit, there is a shaft, then there is a overhead and there is a machine room. So what should be the pit depth, what should be the overhead? These are certain critical details in designing an elevator. So these are certain specifications what we look at when you are actually procuring an elevator. This is just an example. So the controls, you have AC, variable voltage, variable frequency controls. Operations, a single elevator, simplex and a double elevator or a 2-car group elevator or a duplex elevator, 3-car group, 4-car group, and later when I will talk about something called as grouping more elevators, which is called as destination control system. So you can see AC variable voltage controllers, they come sometimes with regenerative drive, which is a green technology and low power consumption. Permanent magnet gearless machines, again green technology, energy efficient with zero lubrication because no gears are used. Then finishes and different types of false ceiling depending on the product what each elevator vendor provides. Then these are again some more features. Cars, landing doors, variable frequency drives are used in door operation as well. Call buttons, emergency alarm, emergency light, which are the critical features. And you can see here, differently abled features like braille buttons and all. These again the specifications. And roller guide technology for high speed elevators, where instead of guide shoes for better ride quality and comfort, you can use roller guides. And there are safety interfaces like automatic rescue device, door nudging feature, so on and so forth. Now, taller buildings for smarter buildings for future. What are the technologies which have come into elevators? Let's see now. So the taller the building, you can see here Burj Khalifa, which is over 828 meters, which is properly designed to ensure that wait times are no more than 30 seconds after hitting the call button, and it is geared up to withstand emergencies like earthquake, fire. What are the innovations which are happening in future in India? You can see something called as a destination dispatch control system, which is now becoming fairly common. This is like in a group control system, 5 of us are going to say 8th floor. We press button of 8th floor. 5 of us can take 5 different elevators and go to 8th floor, which you can see in the first picture. Then destination control system, which will capture your destination, your 8th floor. It will group all 5 of us for a single elevator, so thereby avoiding 5 different calls, thereby making the elevator traffic flow very efficient. You have something called as double deck elevators. In a landlocked or land deprived cities like Mumbai, New York, Tokyo and all, you can go with double deck elevators where one elevator is having 2 decks lower deck and upper deck. How do you access the upper deck? You take an escalator, go to the upper deck, and efficiently you can transfer in a 20 pax elevator 40 people at a time. And then there are technologies also like twin, where two independent elevators also travel in a single shaft. How does it happen? They use technology similar to aircrafts like Boeing has designed, where two elevators will not collide in mid-air. So flights do not collide in mid-air. Similarly, elevators do not collide in the shaft. They have safety mechanism to stop when they come in the close proximity. Then you can also use harness solar power to run your elevators. In small places like in Europe, Australia and all, smaller buildings, they are doing it practically. India also very soon probably this could come in. Now coming to high-rise buildings, now you see in Bangalore, Hyderabad, Mumbai, Delhi, even in India, like other cities like New York, Dubai, Tokyo, you have very tall buildings like 50 floors, 60 floors and above. So what are the minimum aspects which should be taken care of? Like when you are designing for a very high speed elevator, one is a piston effect, building sway and the stack effect. Piston effect is nothing but when the elevator travels at high speeds in a enclosed shaft, it's like a piston. When it piston comes down at a speeds of 3.5 meter or 4 meter per second, it acts as a piston and the air is displayed. When the air is displayed is not properly addressed, the displaced air travels at double the speed of the elevator speed. So there is lot of vibration which it can create, and if there are undulances in the elevator shaft, it can create lot of noises causing lot of discomfort in the elevator shaft. How do you mitigate a piston effect? By creating air vent holes in the shafts, in the partition walls in the shaft, so that when the air is pushed down, it is transferred into the other shaft. When the other elevator comes, the air is pushed to this side, so that the piston effect is mitigated. Then what is building sway? Tall buildings have a little sway in general. Elevators have lot of ropes and all. Then these ropes, steel ropes, are compensated by adding load compensation chains and the other weighing devices to ensure that this sway is reduced to as much as possible, so that no vibration, no jerks are there in the elevators. Then the stack effect is nothing but again causing the pressure differences, because atmospheric pressure is different, the building pressure is different, it should not affect the elevator system running in. So the elevators, high speed elevators, are designed in a aerodynamic fashion, like a different design to ensure that this stack effect is mitigated and the pressure differences is also to the extent possible are reduced. So same thing what I have mentioned about piston effect, I will show some visuals. This is building sway. Stack effect is the difference in air pressure, and the elevator lobbies are pressurized to ensure that this stack effect is minimized. Soundproofing, again lot of technology techniques are there, how to ensure that not minimalistic sound is being heard only in the elevator and the ride quality is most comfortable. So this we spoke about. You can see in a car which is having a bigger shaft, you will have that wind shear is reduced, so that piston effect is mitigated to large extent. So you can also see the air vent holes or the outlets in the partition walls. The buffeting noise, as I was telling you, if there are any undulations or any projections in the shaft, this can affect the this thing, causing vibrations and noises. So that we need to ensure as architects or the civil engineers to decide that the elevator shafts are proper and plumb and clean and neat. Machine room noise, the codes also give what kind of decibels should be there. how much should be the machine noise, and the elevator vendors ensure that they provide sort of noise mitigating mechanisms to ensure that sound vibrations are well within the desirable levels. Now escalators are again mass movement when it has to happen in say malls, in multiplexes, in infrastructures like airports, metros and all. From floor to floor, if people have to be transferred with zero waiting time, escalators are the solutions. You can see the working of escalators. Basically, how much rise is considered? Angle of inclination of escalators are basically 30 and 35 degrees. Why 30 and 35 degrees? Because it has to ensure that at 30 and 35 degrees only, humans can stand comfortably and travel in a inclined height. So these are escalator going up. These yellow lines are to ensure that you safely stand within the yellow lines. There are certain innovations done by companies like Mitsubishi, where spiral escalators are designed to have aesthetic appeal. Then there are moving walkways you would have seen in airports to travel distances, longer horizontal distances with your luggages. Similar to escalator design in hypermarkets, travelators will come in angles of 0 degree, 10 degree and 12 degree inclinations to carry your trolleys in hypermarket from one level to other level. Yeah, this is a hypermarket moving walk, you can see, inclined walkways. So what are the things to remember? You need to ensure that the shaft sizes are properly designed to ensure what capacities are designed for elevators. Your rough wall openings in this thing to accommodate your doors have to be given in such a way that the plumpness of the entire shaft is properly maintained by aligning all the landing doors and the car door aligning with all the landing doors. Then it has to be confirmed with Indian Electricity Acts, confirmed with Indian standards IS 17900 now, and there are fire regulations. Fire department very clearly sees what should be the norms of a fire elevator, and it is all installed elevator, one of the elevator is a fire elevator, designated fire elevator, along with the fire tower which is being provided in almost all the tall buildings. And basic safety guidelines we need to follow. Full body protection should be there in the sites. Entrance barricading should be done. Proper scaffolding should be there for people to go up in the shafts safely. Fall protection on the car top, safety nets, lighting proper and ventilation in the machine room and hoistway, pit ladder to access deeper pit areas, waterproofing so that no water enters because it's a electromechanical installation. And coming to green elevators or sustainable elevators, though green elevators do not provide direct points in terms of IGBC or LEED ratings, but there are a lot of technology being used like gearless technology, no oil, coated steel belts, it avoids rope lubrication. Ropes require larger diameter, bigger shaft, bigger machine, lot of power consumption. In a coated steel belt, it requires only 1/10 of the rope, this thing dia, so that entire thing is compact and the machine is compact and energy efficient. And regenerative drives to generate clean power, capture it and send it to building grid. Car aesthetics with disabled friendly features. As I told you, though directly elevators do not contribute, but it is important in fundamental commissioning that elevators are energy efficient. These are some of the credits which are given in green building ratings. Thank you. I have taken you through the history, then the elevators, the basics of elevators, escalators and travelators. So, any questions I would like to take now? I'll give you the mic.
My name is Lakshmikant.
Yes, Mr. Lakshmi.
You have just said about twin shaft. Can you elaborate that? Twin elevators.
Twin elevators are nothing but
In one shaft, two elevators travel.
yeah. See, what happens is, it's really not a technology per se, but it is a proper design. On the top of twin elevators, you have two machine rooms. The upper elevator, which is traveling above the lower elevator, that has a regular elevator shaft, elevator machine room. The lower deck, which is the lower elevator, has a higher machine room where there are pulleys which extend the ropes, and the ropes are taken down and again connected to the lower elevator, and that operates independently. So that is how the twin technology works. It's not basically any control technology, but it is more to do with the design. And in India we do not still have a single installation of twin, but it's a German technology.
Thank you.
Yes, please.
Thank you very much, sir. I would like to hear about the sustainability in elevators. You just
What is it?
sustainable elevators. You have
Yeah.
just showed. Can you throw some light on it, please?
Yeah, sustainable elevators, as I was showing in my presentation also, one thing is, whenever a manufacturer he makes his product in the factory, you take all the reputed manufacturers, they ensure that 95% of that equipment after it serves its life, basically elevator life cycle is like taken as 20 years. After the life, even if the elevator is dismantled, 95% of that material can be recycled. Only 5% goes to the landfill. That is the kind of high level of sustainability which is incorporated into the product. And when it comes to energy efficiency, gearless machines, coated steel belts, regenerative drives, VF door operators, all these, and destination control systems, all these also will add to the energy efficiency of the elevators, so that it becomes more sustainable, contributes to the green building design as well. Yes, please.
Sir, ready-made concrete ge very
I am not able to hear you.
ready-made concrete ge very ಆಗುತ್ತಲ್ಲ sir. Like IS code prefer ಮಾಡಿರಲ್ಲ ಇವಾಗ for building we will refer IS code
Don't move
1970.
your mic. Don't move your mic. Just start.
ಇವಾಗ buildings
Up.
normal buildings ge we know that we will refer IS code 1970.
Correct.
Okay. But for ready-made buildings, we don't know the code, refer code. How we will do or refer.
See, BIS, Bureau of Indian Standards, has a website. If you type elevators, you will get the complete list of the codes which are available for elevators. Now IS 14665 is has been replaced with IS 17990, which is a standard for designing elevators, installing elevators, and servicing, maintaining the elevators. There are a lot of other codes written clearly for hydraulic elevators, dumb waiters, physically challenged people when they use elevator, how it is. And apart from IS codes, you have National Building Code 2016, Part 8, 5A, which covers elevators, 5B, which covers escalators. It has been complete detailing has been given. It is exactly replicating IS codes in National Building Code. Most of the architects and developers, they now follow National Building Code. Internationally, there is a universal code also we are all working on, which is called ISO 8100-32, which will be a universal code across Europe, Asian countries, and the American countries. Japan, of course, have their own codes called Japan Installation Code. Thank you. Any more questions?
Hi, maybe my question is not related to the presentation, but I'm just keen to understand that what would be the future for hydraulics?
Hydraulic elevators.
Yeah, hydraulics elevator. Do we have scope for hydraulic elevators in India?
See, there is a market for hydraulic elevators, but unfortunately there may not be a big volume currently in hydraulic elevators. That's the reason if you see any multinational, if you take, nobody manufactures a hydraulic elevator. Just for the reason probably it's not going to boost up their business growth as much. But otherwise, there is need for hydraulic elevators where you cannot provide a pit or the pit is minimal. Hydraulic elevator will require a pit of say 250 to 300 mm, and the overhead what is required is not regular like 4 meters, 5 meters, just 3 meters is enough. Only challenge what happens is hydraulic elevators run with oil within the cylinder and piston. So you have to ensure the right temperature is maintained around the elevator, like you are installed in a cooler atmosphere or air conditioned residence, then it will work well without any issue. In hotter climates and all, probably the viscosity of the hydraulic elevator can have a challenge. The other thing what is now happening is a lot of high rise building luxury elevators are being provided. Top two floors are being designed as duplex or triplex apartments. So internally if you want to do, you cannot have a hanging pit which has a pit of 1.6 meters and all. So there hydraulic lifts are the solution. Now when I say multinationals are not doing it, lot of good companies, local companies which are there almost in all the cities, they import those hydraulic kits and align them or mix them with their local hardware and ensure that they provide a proper hydraulic elevator. So the market for hydraulic elevators is going to grow only, it's not going to reduce. It's high time that the regular manufacturers, multinationals also look at hydraulics as a serious product range for them.
Thank you so much.
Any questions? Yeah.
So there is a codes are available NBC to IEN. Even though the states having separate code, what code they want to follow in finally?
Krishnan, I am not.
Sorry, the rest we are following the codes.
Correct.
But every state has a different.
Correct.
Finally, which code should be applied for the state or we want to follow the same NBC or EN?
See, ideally, if you talk about our south states, in Tamil Nadu, Kerala, Karnataka, you have Karnataka Lift Act, Tamil Nadu Lift Act, then you have Kerala Lift Act and all. If you take Andhra Pradesh and Telangana, there is no CEIG, no Lift Act at all. And anybody, even now collapsible gates are being installed there. Ideally, what you need to do is follow the National Building Code. National Building Code also gives a proper how do you install elevator, how do you maintain elevator. But if you are in Karnataka, better to be abreast of the latest what Karnataka Lift Act is giving or the Electrical Inspectorate is giving. Ensure that those are also there. So when as consultant, when I specify in Bangalore, I know locally also what are the features I need to add. So similarly in Tamil Nadu there could be few things from the fire department or CEIG which are specific to the region. But right now we are all fighting for a national lift policy where across the country there is one lift policy which the local government bodies, the national government, all the elevator companies follow. Say there will be a uniform code which probably sooner or later our voice will be heard by the government, sooner something happens on that. Thank you. So if there are no more questions, thank you. I hope you learnt from the presentation.
Thank you so much, sir, for this wonderful workshop. As we draw near to the conclusion of our enlightening workshop on the fundamentals of elevator, it's my honor to extend our deepest gratitude to Mr. Jagdish Kumar, sir. Your expertise has illuminated our understanding of this essential aspect of modern infrastructure. Throughout this workshop, Sir has not only shared their extensive knowledge, but he also inspired us with his passion for elevators. On behalf of everyone present here, I extend our heartfelt appreciation for your dedication, sir. Your commitment towards educating and empowering the next generation of elevators professionals is truly commendable. As we conclude this session, let us carry forward the lessons learned and continue to strive for excellence in our respective roles. Once again, thank you for your incredible contribution to this workshop. So can we have a round of applause, please? So with that, we come to an end of the Elevator World India Summit 2024. Thank you so much all